This is a slide I've shown previously in the interfaces section of the course, mainly to introduce you to the differences between a field declared on an interface and a field declared on a class. When you use the final modifier, you prevent any further modifications to that component. A final method means it can't be overridden by a subclass. A final field means an object's field can't be reassigned or given a different value after its initialization. A final static field is a class field that can't be reassigned or given a different value after the class's initialization process. A field declared on an interface is always public, static, and final. A final class can't be overridden, meaning no class can use it in the extends clause. A final variable in a block of code means that once it's assigned a value, any remaining code in the block can't change it. And a final method parameter means that you can't assign a different value to that parameter in the method code block. In this video, I'll review all of these uses of the final modifier in more detail. You can use the final modifier on methods. Using final with methods only makes sense in the context of wanting to restrict what your subclasses can override or hide. Using final on an instance method means subclasses can't override it. Using final on a class static method means subclasses can't hide it. Let's switch over to some code and examine these two different scenarios. I've created a new project called Final Explored for this video with the standard main class. Before I include anything in this class, I'm going to create a class called base class in a generic package under dev.lpa. Let's imagine that you've been tasked to write a library class, and although it should be extensible, you are told that not everything should be customizable. This class will have three methods. The first, a public method, is there to control the workflow, and it's expected this method will always be called. I'm going to make it public and void and call it recommended method. I'll print that this is on the base class, and this is the best way to do it. This code has a method where optional code could go or extensions could be made. This will be via a call to optional method. There's also a mandatory method, which this base class expects to be executed for every instance. I'll add optional method next. This will be protected, meaning the only classes that can call it are subclasses or classes in the same package as this class. I'll just print that this is on base class, and it's meant to be customizable or optional. Next, I want the mandatory method. This one is private, because I don't want subclasses to alter or override this code. I'll print that this method is on base class, and this code is non-negotiable. This feels like a solid way to allow a little bit of customization, but still have most subclasses execute the same workflow. Now I'm going to emulate a class that might use my library class. I'll create a new class calling that child class. To keep it more real, I'll put this in completely different package structure. My new class name is consumer.specific.childClass, and I want it to extend base class here. If you have auto imports enabled in IntelliJ, it should add the import automatically for dev.lpa.generic.baseClass. If not, you'll need to manually add it. Doing nothing else, I should be able to create instances of both classes, executing the recommended method on both. I'll do this in the main method on my main class. I'll create an instance of a base class and assign it a base class reference named parent. I'll then create an instance of child class, assigning it a child class reference, and I'll call that child. I also want an instance of a child class, but I'm going to assign this one to a base class reference type. I'll call that child referred to as base for clarity. Next, I'll call my recommended method on each of those instances. First, I'll call recommended method on the parent instance. I'll put a separator line between lines of output. I'll call the same method on child referred to as base, that's assigned to a base class reference. And another separator line. And call recommended method on child this time, which is an instance of child class, if I run this code. The results are all the same as you'd expect for all three instances. Now let's say the designer of the child subclass reads our specification and learns they should override the optional method if they want some custom functionality. I will go to the child class and use IntelliJ's override tools to generate this method. I'll customize this. I'm okay with the code that's on the base class, but I want to include some extra functionality before that executes. I'll just add a statement that some extra stuff happened. I'll go back to the main class and rerun this, You can see for the two child instances, the last two output segments show that the optional method on child was executed and the statements child extra stuff here is printed. Our library class is being utilised as designed, and this is what we used to call SWAD, System Works as Designed. But now let's say the subclass designer decides to override the recommended method on his own class. I will go back to child class now to make the change. It is after all only recommended. Again, I'll use the override tools to generate an override for recommended method. The designer of this class didn't read the specification, or maybe we forgot to mention that if you do this, you should always call super's recommended method. Now I'm going to completely replace that statement with my own code. I'll just print that I'll do things my way, and I'll remember to call optional method. Back to the main class, I'll rerun the code again. The two child instances demonstrate that they're not following our best practices suggestion. They've customized the entire workflow, and even worse, the non-negotiable method is never run. Since it can't be accessed by subclasses, they can't even invoke it. What choices do you have now? You could make the non-negotiable method we called mandatory method protected, so subclasses can call it, but that still puts the onus of invoking it on the subclasses. You could recommend that designers of subclasses copy and paste the mandatory method into the subclass. That takes all the control of that functionality away from the base class. If the base class makes a change to its private mandatory method, how will it broadcast to all the subclasses that they should change their copies? The better solution is to make the recommended method final on the base class. Let me go back to the base class and do that. Adding final to the recommended method. The subclass, child class, doesn't compile now. When you make a method final, a subclass can't override it. I'll comment out this method. Now, the only code the subclass can override is the optional method, which is exactly what I want. I now have control over the functionality of subclasses where it's important. I've used final and designed the methods accessed by the final method in various ways, as I've shown you here. For code that's non-negotiable, I can make that private, or alternatively, I could make that final. What happens if I add final to a private method? Let me go back to the base class and try that, adding final to my mandatory method. Notice that IntelliJ has grayed out the final keyword in this case. I'll come back to that in just a moment. I want to first jump back to the child class and override the mandatory method. If you try to do this using IntelliJ's override help, you won't see this method listed. I will type this method out using the same signature. I'll add a print statement, so child's mandatory method, my own important stuff. Okay, there's a couple of things I want to point out here. First, this isn't an override. You can't override methods that are private on a base class. Second, I was able to create this method even though I added final on the base class's method. The modifiers private and final are somewhat redundant. When a method is private, no other class, including subclasses, have access to it, and therefore any code that calls it will only execute the code on the class where it's declared. To put it another way, using the private modifier means this method will never be polymorphic. That means if I run my code now, even though I have my own private method called mandatory method on the child, it's never going to be the method that's executed from the recommended method on base class. I'll go back to the main class and rerun this. And you can see for all instances the non-negotiable statement, meaning the private method on base class was executed every time. Getting back to the base class, let's see why IntelliJ has grayed that out. Although the message isn't great private method declared final, the suggestion is to remove the final modifier. It's redundant for private methods, but not a compiler error. I'll remove that keyword from this method. Now, I want to compare instance methods with static methods for a few minutes. I'm going to create 3 static methods on my base class. These will be similar to the instance methods, so first a public one I'll call recommended static. It will print that this is base class recommend static and the best way to do it. It will in turn call optional static and mandatory static methods. I'll create the optional static method next, and that's protected and static. This will print that it's the optional static method on base class. Lastly, I need the mandatory static method, and that will be private and static. This will print that it's the mandatory static method on base class. Getting back to the main method on the main class, I'll insert a separator line on line 20. I'll copy the statements from line 14 to 18, pasting that at the end of the main method. I'll change each of the method calls to call the static methods, so I'll replace method with static on lines 21, 23, and lastly, line 25 there. Okay, so maybe you're wondering why I'm calling static methods using instance references, meaning using parent and child rather than base class and child class. Although I can do this and the code compiles, IntelliJ is highlighting each of these calls. I've discussed this previously, and IntelliJ is good at reminding us that calling a static method using an instance reference isn't a great idea. I'm going to leave the code this way and run it anyway. Because these methods are only on base class right now, all three segments, the last three segments in the output, are the same. This feels like a good place to pause in this discussion before this video gets too long. I'll be coming back to this example in the next video to explain what is really going on. See you in the next video.